real-time spectrum analyzers fundamentally collect and display frequency data differently than swept spectrum analyzers. Today we will discuss the operational difference and look at an example. A swept spectrum analyzer captures the amount of power detected in a small frequency span called the resolution bandwidth. It will post this power to the display and then go on to the next span. It will capture the power in the signal, often hundreds of times, as the frequency being measured moves across the display. This creates accurate measurements, but can miss events that occur in one frequency when a different frequency was being evaluated. A real-time spectrum analyzer captures the signal in the time domain. This single, continuous data capture is then separated into different frequencies using fast Fourier transforms. The combination of these FFTs creates a single scan across the entire frequency range from a single set of underlying data. Because the instrument is capturing all of the frequencies of interest at once, it is able to capture more transient signals. Let's look at an example monitoring the 2.4 GHz band. Because the detector sweeps across the span, the instrument can't capture all the frequency components at once. Typical sweeping analyzer sweep times are measured in milliseconds to seconds. The RSA 5000 works as a sweeping analyzer for important high-accuracy characterization, but even in a fast sweep, it can't quickly show activity in the Wi-Fi or Bluetooth bands. Here, we are sweeping every 4 milliseconds with a 100 kHz RBW, but still often miss the Wi-Fi and Bluetooth activity. To improve the capture, we have turned on the max hold trace in blue. This shows us all the activity captured over the last 10 minutes or so. Because these signals change quickly between channels and have short on times to conserve power and limit interference, they are difficult to capture with a swept analyzer. Now let's switch to real-time mode. Immediately, our density plot shows multiple complete Wi-Fi and Bluetooth signals above 2.4 GHz. We can see the Bluetooth signals moving among the Bluetooth channels to avoid interference. Over the same span as the swept analyzer, with 100 kHz RBW, real-time analysis shows complete signals continuously in real time. We can change to the combined spectrogram view to visualize the signal timing behaviors as well. Real-time spectrum analyzers call the ability to capture short-duration transient signals the 100% POI, or probability of intercept. It is measured in time and indicates the shortest signal that is guaranteed to be captured. The RSA 5000 can be set for 100% POI as short as 7.45 microseconds. This is accomplished by the calculation of more than 145,000 FFTs every second within the instrument. By capturing all the frequency components of a signal at once, a real-time spectrum analyzer makes it much easier to visualize transient RF signals compared to a sweeping analyzer. A real-time spectrum analyzer calls its ability to guarantee transient signal captures the 100% POI time.